This is the second part of the lesson in which we review different chart types in Data Studio. We learn how and when to use them, plus some data visualization best practices. Hi, this is Ahmed from Siawak with another lesson from Google Data Studio Essentials. In the previous part, we covered the scorecard, table, time series, area chart, and bar chart. If you haven't watched that, it's completely fine. You can watch it later. In this part, we're going to cover the map, the pie chart, the scatter chart and bubble chart, the tree map, the pivot table, and the bullet chart. Let's go ahead and get started. And that's a map. So with a map chart, we can visualize the difference of a metric across different geographical locations. Here I have users by country, and on the map, the more the number of users, the darker would be the shade of the color. So without looking at any other data within this dataset, we know that this is a website that gets the most of its audience from United States. And now that we understand this, we can zoom into United States and see the number of users per state, like this. And here we can see California is the outlier with the largest number of users. Now this is the old legacy map chart in Google Data Studio. Recently, a new map chart has been introduced, and that's the Google map. Here we can see users per city. The first difference that we can notice on this Google map is that instead of shaded regions, the numbers are plotted as dots and bubbles on the map. Here, each bubble represents a city, and the size of the bubble represents the number of users that we've had from that city. Another cool feature of a Google map is that we can pan around and zoom in to see more details about the areas that we're interested in. Here's another example of a Google map. Here we are seeing the users and revenue per city worldwide. In this chart, the size of the bubble again represents the number of users, but the color of the bubble represents the amount of revenue. If it's white, it means that we had basically no revenue for that city, Florence in Italy. And if it's orange, it means that we had a large amount of revenue from that city. So for example, this bubble is both larger in size, meaning more users, and more orange in color, which means more revenue. Now what I can do is that I can click on this table to filter the Google map, and it automatically zooms on the United States to show me the data only from the cities within the US. This is another example, the same map, and the only thing that I've changed is the styling. So it looks much more like a Google map. Now again, if I click the table to filter the map only for New York City, it automatically zooms on the selected city. That was cooler than a bar chart, wasn't it? But that's all about the maps for today, and let's go see another exciting example, a pie chart. Pie charts are interesting. Almost every data visualization expert that I know of hates pie charts, and they have good reasons for that. Not only it takes so much unnecessary space on the report, but also the human brain isn't really good at comparing the lengths of curved lines or comparing the angles with different angles. Okay, that's why that the viewers of this report will have a hard time to extract some insight and meanings from this chart just by taking a look at the visuals. And if they want to see and compare the actual values, they have to move their mouse around all of these sections of the pie chart one by one. If the report is printed, they just see this. But just like any other types of data visualization, pie charts can be used correctly or incorrectly. My rule of thumb is that if I can visualize my data using any other chart type, I usually don't use pie charts. But if you have to use them, if you want to use them, there are some guidelines that you can follow to have a better pie chart that the viewers of your report can actually understand. First of all, the fewer categories, the better. Here's an example of 10 categories. This one has 6 categories, age range a bit more clear. This one starts to become a good example. Just 3 categories, we can easily see that desktop has the largest number, followed by mobile and then tablet. And then probably the best usage of a pie chart is when our dimension only has 2 categories, new visitor versus returning visitor, male versus female. Now, some people, they didn't like pies, so they created a blank circle within a pie to make a donut chart. But that's basically the same. the same rules apply. But what if you have more than 2 or 3 categories? What are your alternatives? Here I have 2 alternatives for you. So instead of a pie chart, consider using a bar chart. The human brain can see the difference of the lengths of straight lines much more easily, especially if they are laid out side by side. And if you want to save space, you can also use a 100% stacked bar chart with just 1 bar. Enough about pies and donuts. Let's move on to the next chart type. Scatter and bubble chart are usually a bit more complicated and harder to understand for the viewer of the report. It usually takes more time to process the data presented in this way. Try to keep your audience in mind and stay away from using more complex charts like this, like a scatter and bubble chart, unless you know that the viewers of your report are really familiar with these types of data, or they are ready to spend some more time to understand the data that is visualized this way. But I'm going to just show you a few examples so you know what's possible to do with this chart type. They are good to show relationship between 2 metrics with the dimension as they break down. So for example, here I have transactions and average order value, and we're using the US state as the breakdown dimension. So here we can see the outlier, California, which has the largest number of transactions and a fairly high average order value. There are 4 other states that have higher average order value, but they have few transactions. Now we can make it even more complicated by introducing an additional third dimension. So for example, here, now I have the same metrics, transactions, average order value, but this time I'm breaking them down based on the browser, and also I'm using bubble size to show the e-commerce conversion rate. So again, we can immediately see the outliers. Chrome with the largest number of transactions, a fairly high average order value, and the largest e-commerce conversion rate. Over here, Firefox with the largest average order value, but just a few transactions, and by few I mean compared to the more than 16,000 transactions on Chrome, and then the rest of the browsers with a low number of transactions and a lower average order value. So if the owner of this business wants to optimize their website for different browsers, they can use this chart to quickly see where they should spend their resources. Another example, again, transactions, average order value, and e-commerce conversion rate as the bubble size, but this time broken down by device category, desktop, mobile, and tablet. Again, we can see that desktop is responsible for the largest number of transactions and the highest average order value. Plus, it has the largest e-commerce conversion rate as well. A different example, we want to see which channel is bringing more traffic and more revenue. And because the amount of revenue for this dataset had a really wide range of somewhere close to $1,000 to over $1 million, I had to use the logarithmic scale for the x-axis. With the log scale for the horizontal axis, each step here is 10 times more than the previous step. So 100K, 10K, 1,000, 100, 10, and 1. Now let's read the data. So referral has about 100K users with more than $1 million in revenue. Over here, organic search has about 350,000 users, but somewhere close to $500,000 in revenue. Feel free to pause the video and try to interpret the chart. As you can see, it takes much more brain power and time to process a chart like this rather than a simple trend line or a bar chart or a combo chart. Okay, that's enough time spent on the scatter and bubble chart. Let's go and see the tree map. Tree map lets us compare the value of one metric across the categories of one dimension, like this, and it shows the high values with a darker shade of color and also by allocating a larger area to that category. Here we can see that Nest Hello Doorbell was responsible for the largest amount of revenue across all products. But something else that we notice is that many of these are in the Nest category. They are Nest products. So let's take a look at a different way of using the tree map. Now I applied 2 dimensions to tree map, product and product category. Now instead of all Nest products being scattered around different places on the chart, they're all inside this rectangle that I'm showing with my mouse pointer. Okay, so this is all Nest, this is our apparel, this is all office product, drinkware product, etc. So we can see the size of revenue for each category, and within that category we can see which one of the products had the largest amount of revenue. But as you can see, this is too complicated. There are so many categories. A good practice for using tree maps is to use a dimension that has fewer categories in it. Like here that I've just applied product category. So we can immediately see that Nest as a category has the largest amount of revenue across all different categories for this shop. And before we say goodbye to tree map, here's another example of using a dimension with few categories, age range, and see which category has the largest amount of revenue. We only have two more charts left, pivot table and bullet chart. Let's take a look at pivot tables. Pivot tables are good for summarizing large tables with several dimensions and metrics into a cleaner, simpler way. Here I'm showing product revenue and quantity per product category. And I'm using bars so we can quickly compare the numbers. Now the first difference of a pivot table and a table is that it highlights the rows as we move our cursor across different categories. And you might have noticed this plot sign here, and that in the title I said product revenue and quantity, which we can see per product and product category. But the only thing that we can see here is the product category. Where is the product? If we click on this plus sign, we can expand the pivot table. So for each category, it can list all the products within that category. And we can see line items, the revenue for that product only. Now, if we scroll down slowly to reach the end of the Nest category, we can see the subtotal for the Nest category for all product was close to $2 million in revenue and close to 15,000 quantities sold, which is the same amount that we can see for the whole category if we collapse the columns, this and this. At the bottom, we can see the grand total for all categories. Let's take a look at another example of a pivot table. The previous one was kind of like a normal table, but with the expandable column of product. But this one is completely different. Instead of having dimensions represented as rows and metrics represented in columns, we have a dimension, product category, in rows, and we also have another dimension, the channel, the default channel grouping, represented in columns. So for each product category, we can see how much revenue did we make from referral, how much from direct, how much from organic search. And then for each of these categories, we can see how much did we make in total. And over the right, we can see how much did we make from each product category regardless of channel, again in total. And you already know about the plus sign. If I click on this, I can expand product category to see the product within each category. So for each product, how much did we make from referral, how much from direct, how much from organic search, and then how much in total. Just like the previous example, if we scroll down to the end of the Nest category, we can see the subtotal for that category. That's it, all about the pivot table. Let's move on to the final chart, bullet chart. Bullet charts are simple. They show the performance of one metric compared to a target. Plus, we can set three different ranges, the low range, the mid range, and the high range, using shades of a color. Let's take a look at this one. E-commerce conversion rate. It shows 2%, but it's because it is a compact number with no decimals. We can see that it is actually somewhere between 1.5 and 2%. Now the target on this is set to 2%. We can set the target on whichever number that we want. It is part of the chart settings. And this is usually something that the business owner should decide. Okay, do they want 2% e-commerce conversion rate? Is this something that they're happy with? Is this something that they are trying to achieve? Okay, and also we can set three ranges. The low range, which is usually considered bad. So if e-commerce conversion rate is less than 1%, it's really bad performance. If it's somewhere between 1 and 2%, mid-range, it's quite acceptable. And then 2% and anything above that is considered good. Now we can choose to show just one bar for this time period, or we can choose to compare it with the previous time period. So for example, in this case, we can see that in the previous period, the e-commerce conversion rate was in the good range, 2.5%. But in this time period, it's less than the target, but is still in the acceptable range. As another example, we can have the same for revenue. So they have a target of 2 million. Anything less than 1.5 million is considered bad. Anything between 1.5 million and 2.5 million is considered acceptable. And then anything above that is good. Now in this period, they hit the target and they actually overperformed. They made close to $3 million in revenue, which is good, right? $3 million. But then we see the comparison and we notice that in the previous period, they had made close to $5 million in revenue. So despite hitting the target, despite being in a good range, they're not making as much money that they used to make in the previous time period. Now, based on this data, the owners of this business might want to actually move the target for the next period from $2 million to somewhere closer to $3 or $4 million. Okay, that's it. Congratulations. Thank you for staying with me. You notice that I couldn't actually show you how to set up and configure all of these charts because that would have taken so much time. But at least you know what's possible and what kind of options do you have when you want to visualize data and communicate insights to the viewers of your reports. These are your tools for when you want to tell a story with your dataset. We've just reviewed all different chart types in Data Studio as of June 2020. As you noticed, I couldn't actually show you how to set up and configure all of those chart types. It would have taken too long. But at least right now we know what is possible in Data Studio in terms of data visualization and what kind of tools do we have to communicate different kind of insight to the end user of our report. It's good to know that it's possible for anyone to create a custom chart type for Data Studio. They're called community visualizations, and that's the subject of our next lesson. Did you learn anything new today? Feel free to test your knowledge by taking the quiz or continue to the next lesson. As always, you can find both links in the description below. If you're new to Measure School, make sure to subscribe so you can get notified of the future videos that we publish. And if you have any questions, please feel free to leave a comment. I look forward to seeing you in the next lesson.